Throughout the world, and even beyond, these and thousands of others are benefiting from the work of the world's leading map maker, the United States Army. Since the beginning of time, man looked around and wondered, what lies beyond the next hill? What lies beyond the horizon? And as he trod the earth, he sought to mark his way, to name places and things, to measure distances, to improve his way of life, to explore new lands, to reach out farther and farther. As his world expanded, his ways of making maps improved. Today, modern topographic mapmaking originates here at Topocom, the Army's topographic command just outside Washington, D.C., the world's largest mapping agency. Their work benefits the lives of thousands of people in many lands. The Army pioneered development of the plastic relief map that has quite literally brought a new dimension to maps. An operator who combines his mapping knowledge with a precision cutting instrument begins the job as he traces from a contour map to cut the first stepped landform replica from a laminated plastic block. It doesn't look much like the Earth's surface yet, but that'll be taken care of on a plaster cast. The plaster cast is carved and shaped into a precise miniature replica of the terrain. Here, in the final step, a flat plastic map is formed into a three-dimensional map. It's done in seconds by employing heat and vacuum. The map comes out endowed with hills and valleys in all the right places. Always in the forefront of advances in their field, Army mappers began using space science several years ago with the launching of a small rocket. It put into orbit the Secor satellite, which has become a major advance in accurate mapping. The signals transmitted to Earth from the satellite seek out the specific location of an unknown point by geometrically linking three established ground locations. Sophisticated ground stations track the precise path of the satellite. The Secor belt connects islands 4,000 miles apart and is a part of a worldwide system telling us for the first time the true size and shape of the Earth. Besides correcting navigational errors, it ties the world together for all time to come as a single mapping unit. American astronauts on their way to the moon carry maps of the lunar surface with incredibly fine detail. In this special Topocom project for NASA, Army scientists are mapping the moon. The source material is, as always, aerial photography. But these pictures taken by the Ranger, Orbiter, and Surveyor spacecraft were transmitted back to Earth by radio in small bits and pieces. Assembled, the fragments become a large, highly refined mosaic. First proof of the mapmaker's success in depicting the lunar surface came on the Apollo 8 mission, that monumental voyage around the moon and home again. On their first lunar orbit, the astronauts began radioing back to Earth about the landmarks they were passing, the craters Messier and Pickering, the Pyrenees Mountains, the seas of fertility and tranquility, landmarks they were able to identify from the detailed lunar maps they carried on board. On Earth, those prosaic radio messages brought elation to every Army mapmaker who had worked for so long to create those unique, unprecedented maps. This looks like the moon, but it's just a model at the Manned Spacecraft Center in Houston. Here, the astronauts practice the ticklish job of maneuvering to the selected landing spot and making a gentle touchdown. A model is a scale replica of the actual area chosen for the landing. And it was constructed from maps like those prepared by the Army. In these drills, the astronauts must identify the correct spot. Then, firing brief blasts from their steering and deceleration jets, they move into position and gently lower themselves onto the surface. The astronauts themselves gave silent testimony to the realism of this practice by their tense alertness, as if they were in fact landing on the moon.
30 seconds, down 2.5. Forward. Forward. 40 feet, down 2.5. Picking up some dust. 30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward. Drift into the right a little. Okay, engine stop. APA at a descent. Mode control both auto, descent engine command override off. Engine arm off. 413 is in. Houston, Tranquility Base here. The Eagle has landed. I'm at the foot of the ladder. I'm going to step off the limb now. That's one small step for man, one giant...
The mapmakers' efforts were truly justified when American astronauts became the first men in history to walk on the moon.
With a relatively level plain cratered with a fairly large number of craters of the 5 to 50-foot variety. The surface is fine and powdery. I can pick it up loosely with my toe. It does adhere in fine layers, like powdered charcoal, to the sole and sides of my boot. Airmen from the planet Earth first set foot upon the moon, July 1969 AD. It came in peace for all mankind. It has the crew members' signatures and the signature of the President of the United States.
The research and development that has made the Army an international leader in mapping goes on at the Engineer Topographic Laboratories, a few miles outside the nation's capital. Army scientists are laying foundations for the future, finding ways to improve the accuracy and value of maps and the speed at which they can be produced. They are finding out how the fantastic light of the laser can ease the burden of the field surveyor. The laser's thin, powerful beam can measure up to 50 miles. Imagine two hills some distance apart. A ground surveyor must make 5 or 10 measurements to find out the exact distance. With a laser, he can do it in a single measurement, in moments, saving strenuous days of hacking through jungles or climbing mountains.
Since the beginning of man's history, the making of a map has been a key factor in the growth and progress of civilization. Today, map making continues to play a major role in both military and civilian uses, and the Army Topographic Command maintains its position as an international leader in mapping a better tomorrow.